Remember that the vector is the physical quantity. They have a magnitude and a direction, which we can represent by an arrow, something like this. And you can see this arrow, the head is pointing toward this direction. That means the vector is toward this direction. And the length here, the length of this arrow will be the magnitude. For example, we have an object, right? We apply the force. Let's call this force F1. You can see the arrow is pointing here, so we apply the force in this direction. And let's say F1 is equals to 1 Newton. This is the magnitude of a force. So this length here, length of the arrow, will represent the 1 Newton. If we have another object like this, we apply some force, something like this. Let's call this F2. And we know this, the length of this F2 vector is twice of this F1. So from here we actually know this, the F2 is given by 2 Newton because the length of this is twice of the F1 and this length represents the magnitude. And you can see both the head of the vector is pointing toward the positive x direction toward here. So we can conclude they have a same direction. Now if we have a third object, we apply the force, let's say something like this, and this is F3 toward the negative x direction. You can see the arrow here is pointing to the opposite side, right? And the length of this is about half of the F1. This is about 1 over 2 of the F1. So from here we can conclude this F3 have a magnitude which 0.5 Newton because the length is only half of the F1 and this is pointing opposite to the to negative x direction, which are opposite to the F1 and F2. Now, of course, the concept I am explaining here apply to all the vectors, something like the displacement, right, and velocity, electric field, etc. So anything we can have a direction and a magnitude are vectors. Here I just use one of it, which is the force, and but the concept is applicable to all others vector.